All right, we're going to do this problem here. So follow along. A balloon that is missing 5.6 times 10 to the 11 electrons is brought 0.07 meters away from another balloon that has a charge of positive 2.9 times 10 to the minus 5 coulombs. Calculate the force between the two balloons. All right, let's go and pick apart this information. So it's missing 5.6 times 10 to the 11 electrons. That is the number of electrons, so that's going to be my variable n. And then it is brought 0.7 meters away. Meters, that's a distance, so this is going to be my variable d. From another balloon that has a charge of 2.9 times 10 to the minus 5 coulombs. So this is going to be one of my q variables. Remember, we have one. We can have q1, q2. We'll call it q2. Doesn't really matter which one we call it. Calculate the force. Okay, so this is what we want. We want Fe is what we need to solve for in the end. So if we make a list of our variables, well, first, actually, let's write our equations. This might be easier. So one equation we might use is F equals K Q1 Q2 over D squared. Another equation we might use is Q is equal to NE. Remember, Q is the total charge, N is the number of particles, and E is the charge for every one particle. Okay, so what I like to do is either make a list on the side, or sometimes I'll just do little check marks. So let's do the little check marks here. So we have N, it looks like. E is a constant, K is a constant. Let's check those. Fe is what we're going for. I'm just getting this from the beginning of the problem. So we have N, D. We have D here, so check mark by D. And we have Q2. So if Fe is what we're going for, we may say, hey, let's start with this equation over here. However, we also note that, we don't have Q1. We don't know what Q1 is. So if we were to plug in all our information, K and Q2 and D, and solve for Fe, we'd have another variable. So what we're going to need to do is we're going to need to use this equation to solve for Q first, and then we'll plug Q in here. Let's do a picture of what is going on. So remember, we have two balloons. So here we'll do balloon number 1, balloon number 2. Balloon number 2 has a positive charge. This is balloon number 2. And balloon number 1 is missing some electrons. So, we can draw those electrons going away here. So it's this number of electrons left that balloon. So if the balloon was neutral and then it lost some electrons, it's going to be positive as well. So there's our picture. So now that we have identified our variables from the problem, we've written our equations, and we've identified which variables are missing and what we need to solve, we need to use the equations. We're going to start with this one here, and we're going to do that even though this, the electric force between them is what we want to end up with. We have a second unknown in that equation that we got to solve first. So this is a two-step problem. So let's do this in different color here. So our first step is we're going to use Q equals NE. And what I can do is I can just go back and I can look at my given information where I annotated the problem. And N, I already know what N is. 5.6 times 10 to the 11 electrons. So 5.6 times 10 to the 11. Oops, that looks like 6.6. Fix that. So that many electrons times the fundamental charge for one electron. So if that's how many electrons we got to multiply it by the charge of a single electron, which is 1.6 times 10 to the minus 19 coulombs. And that's going to give us a value for Q. Now what you should do is you should pause the video, put this into your calculators to make sure you're using your calculator correctly. So pause the video, you calculate it, and you're going to compare with my number. All right, you should have gotten 8.96 times 10 to the minus 8 coulombs. So this is the amount of charge, not the number of electrons, but the amount of charge that was pulled off that balloon. So now we know the charge of this balloon here. So now we know our Q1. So we're going to take this value here, and plug it into Q1. Let's see, we'll use blue. So we're going to use our equation Fe equals K Q1 Q2 over D squared, and we're going to plug in some values. Fe is what we're going for. K is our Coulomb's law constant, 9 times 10 to the 9th. That is just going to stay the same. Q1 is what we just solved for. Now, why did I choose Q1 instead of Q2? It does not matter. You can use either one. And here is our Q2. Oops. Our other charge are on the positive here. So that's going to go right there. So 2.9 times 10 to the minus 5. All over the distance between them, 0.07. And then don't forget to square it. Now again, what I want you to do is I want you to pause the video. I want you to plug that mess into your calculator and then come back and see what you get and see if your answer compares to mine, agrees with mine. Okay, so we got an electrostatic force between them of 4.77 newtons. That's what you should get in the end. B, explain how you know if the balloons attract or repel. Well, because we drew our picture, this is very easy. We see positives and positives, and we know positives are going to repel each other. So like charges repel. So they're going to repel because they're both positive. And we're done.